So I think in last session we have discussed about the complete data, like AWS related stuff. We discussed about Amazon Web Services. We talked about what is cloud computing, what is virtualization, what are different cloud models are there. We discussed about some public cloud providers, history and evolutions. We talk about different foundation services of AWS, and in which primarily we discuss about compute, networking, storage, right? Um, so there are a few quick questions. I wanted to understand, like, which services, what are the different analytics services, analysis services in AWS we discussed?
Kinesis.
One of
Then
them.
Data stream,
Uh,
kind of stream,
and
batch.
Athena.
what are the different big data services in AWS?
S3, SQS, EMR,
Redshift,
C2.
Redshift, Athena,
Mm-hmm.
Glue.
Correct.
data streams, Kinesis data streams.
Mm-hmm. And what are the different types in Kinesis?
There one is batch and another is stream, right? One is data stream, analysis.
So Firehouse is there, then the data source is there.
Correct. So in Kinesis, we have Kinesis D stream, we have Kinesis analytics, Kinesis Firehouse, and now we have Kinesis video stream also. These are the stuff. Athena is also there. Then EMR Elastic Map Reduce is there, right? And we have uh, Redshift is for data warehousing purpose. And for business intelligence, we have QuickSight, AWS QuickSight, that is for visualizations and all. So these are services. We discuss about what are the top services over there, and if it is highly scalable, available data pipelines we discussed yesterday. This pipeline we have discussed that how someone new wanted to create a pipeline. So this basic pipeline how someone can go through. This is what the overall objective, the data engineer role, we have already discussed, like we ingest, transform, store, explore, do data management, data science. This is the way we do from the ingesting to the data lake, transforming, data warehouse analysis. Challenges we have already discussed, volume, velocity, variety, veracity, values. Then we have discussed S3. So what are the different S3, types?
Standard.
That is
Uh,
We have standard access and in segment access.
okay.
We have Glacier.
Glacier, then
Now
RR.
in Glacier also there are multiple modes, right?
Correct.
Depending upon the range of years, how you want to retrieve the data.
Hmm.
So
Then we have also RRS, S3 RRS. Reduce redundancy storage. Yeah. So correct. We have discussed these things. We have created that. Then also I have discussed with you about one of the compute service that's called EC2, right? Elastic Cloud Compute. Elastic Cloud Compute will help you to enable virtualization, and you have installed over there a virtual machine, and with the help of you created a virtual machine of Ubuntu Linux based environment. We have installed Spark, and there are certain packages we have installed on the top of it, and that's how we have seen that how we can actually look for that, right? So this was the idea. Today we are planning to first, you know, get this, involved with, uh, to use PySpark, we required a user interface where we can program. So we have installed the Spark and we have seen like a notebook how we can type a PySpark program. But before we jump into that, before we go into that, we required a reliable source of, like a management tool that will allow us to do all the ETL jobs as well as management of all those ETL tasks and, then help us to store, into a data warehouse also. So there is a tool called Databricks, right? So Databricks is one of the tool that will have a cloud-based tool that will allow us to do our big data task, on their, on interface. So the interface of Databricks is like in a such a way so that you can actually write the queries, you can manage the task, you can see the cluster, and you can not just do that, but apart from that, you can actually do a reliable way of, like storing the data, tables, and creating notebooks. So that is how, Databricks is meant for, and it is helpful for us. So we will look around that. But before even we work around the database, let's install or create a user interface or logging into the Databricks account. Okay. So let me just tell you, if we just, here we are here. Before we jump into that, let's say Databricks, just search about Databricks only. Yeah. So you can see that Databricks is nothing but it's a intelligent platform for all your data manipulation, data transformation stuff. And now you can do multiple things, you can do multiple thing on Databricks. They are keep adding multiple stuff and, what I have seen, they are aggressively working with different AI models also, and you can quickly use those models and you can actually apply them. So that is what, and that you can leverage the stuff of, Spark, PySpark, SQL, PySQL, and Scala and all everything on top of it. So we will be going to work around your Databricks. Okay. So for this, if you wanted to set up like your Databricks account on AWS, so there are two types of account you can create. One account is the community version account you can create. So you can create what community version account, and one account you can create a premium account, right? So we can have a look of a premium account also and a community version account also. So let me just show you what's the community version account, how my community version account looks like. So just a second. This is my community version account. Yeah. So this is what my community version account. Basically, this community version account will allow us only give us a 15 GB of like a memory and one single cluster. That cluster will auto off if we are not using it for 4 5 hours or something like that, 2 hours I think so. So that is what this community version account. But I can do almost everything what we can do on their premium account, right? Everything is there. So we will look around this. We will have a look how we can actually use this community version account also. But what you can do, you can create your AWS account. I'm just sharing you steps how you can create your set up your Databricks account on AWS. So one thing is either you can use or set up the account from AWS directly, in which you have to go into the marketplace and then you initiate the process, Or because even though if you go to the marketplace, you are just attaching the workspace on Databricks, or you can directly attach by outside also on AWS. So both ways, okay. This is one of the steps that has been mentioned here. Okay, like what you have to do, which stuff you need to open. So here everything is there. Once you go to the Databricks, you need to choose which cloud provider you want to use. Let's say you want to use Amazon Web Services, you click on Amazon Web Services. Then you have to verify email and log in Databricks. So once you verify your mail, then you need to log into the Databricks. You can create password. Generally, from the last few months, they are not letting us to just directly put password. Rather, they are just allowing us to put the passcode. So that is also you can look around it. So you can create password also. Then you need to pick the Databricks subscription plan. Let's say you are subscribing the premium plan, so you can choose to the premium plan here. So you can select the premium plan. Okay, just a second, guys. Yeah. Hey guys. Yeah. So once you select this premium or something like that, then it will once you started this, like how to set up and all. So once you select these things, like you are selecting an version here on, so here it will allow you to let you to log in into the workspace. Okay. Once your workspace, then you need to like log in your AWS account or something like that, and then it will directly redirect you to the quick create stack. Okay, so once you create the create a stack, some information has to be there, and that need to be debugged. Once it is done, it will create some kind of a stack over there, and we will be able to access our workspace afterwards, and then we will log in, and then you can use your Databricks account and all, right? So
Dipesh, will we be doing this now? Like, setting up the AWS and Databricks together?
yeah, there's a step you need to do now, all of you. So uh,
Dipesh, we need to sign up before, right?
what?
We need to sign up for this Databricks, right? Before
Correct. You should
login.
sign up for Databricks. I
Yeah.
have shared you link. Let me share you this link. Okay. So there are two ways. See, either you can create using AWS marketplace account, like from here you can also do that, or either you can directly create from outside. So let me just show you from outside because it is easier to do. Well, I have already created, so it will be kind of difficult for. Yeah, so either you can, you know, open from directly here. You just search here, data marketplace, basically market AWS marketplace. Here, either you can search of Databricks. This is the AWS marketplace. See, I have already created Databricks intelligence platform here. So you can either, search Databricks intelligence platform in AWS marketplace. Okay, so this is one of my accounts. So you just search Databricks data. So here, this one. So you need to just sign up here, right? You need to just sign up here. Like here, you will get an option to view purchase option in this. You need to subscribe. Yeah. So already I have subscribed. So here you will get an option to subscribe. Hello.
Yeah, we're following Dipesh.
Yeah. So once you subscribe here, and you have to fill some kind of your some information, then further you will be able to like log in by your email ID and all, and then that's how you will be able to make some uh, check the process. So this is what my Databricks. You'll got a email over there. Like this is my where I have you'll get a link. So you will get a link on your email ID where you will be going to log in once you subscribe this. So once you subscribe, you will get an email to log in here. So you need to put your email ID and just continue with that email, and you'll get a verification code. Yeah. So once you log in, this is how something you will get. You all are here?
Yeah, that is.
Yeah.
Then once you click on this, since I have already logged in, so it's going to quick create a stack option you will get here. So here you can see that when I create workspace, here it is two options. One is manually so typically for advanced with AWS SP, you need to create your own storage and credential configuration, or you can use quick start to create a workspace in just a few clicks. So if we quick start here, go next. So here you need to name your workspace. So let's say I'm giving um, and this in what we have used before.
It was North Virginia. Yeah, US East one.
Yeah. Then start quick start. So in AWS stack, this viable file, you can see that we all are here, correct? So we are following this document. See, we all are here now. So once you do that, this login credential has been created. Now in this, what is that? Here, template is here. Just workspace room, IAM role, we are not putting anything. North Virginia is the one that we have selected already. IAM role. So here in IAM role, see IAM role, either we can create our own IAM role, okay? And either we can ask that by default, whatever the IAM role we have, we can put over there. So right now, we can put this, the laptop is the workspace configuration. By default, it will create its own. So specify an existing AWS identity and access management service role the cloud person can assume. So there is no role we have created. Well, it's an optional for now, but acquire capability of IAM role. So once you acknowledge this, okay, that you need to create a stack. Okay, so just create a stack. So now you can see that it's creating this stack. Once the stack created, then we will able to work on Databricks. Okay. Just wait for a while. Are you all following this the same?
Dipesh, can you please repeat what did you select for the permissions?
Permission?
Yeah, before creating the stack.
Stop sharing the screen. Just share your screen.
Okay.
Yeah, so I just acknowledge. So it's an optional, specify an existing AWS identity. So I've not taken up any IAM role, but we need to give an S3 access. Okay. So, we need to check like later on we can apply this, but yeah, when you just select that below, there is I acknowledge the AWS might create IAM resource with custom name. So we are giving an allow that we want it will create by themselves an IAM role. Okay, just
Mhm.
create a stack.
What is the difference between create stack and create change set?
What?
So there is another option just before create stack, create change set.
Change set. I did
Yeah,
not.
change set. You just clicked on create stack, right?
Yeah.
In the previous page. So
Mhm.
just before that create stack, there is another button called create change set.
Need to check. Can you stop share your screen?
Yeah, sure.
Where you're saying? Oh, it's not.
Can you go to the previous page?
Oh, it's not created. Anyways, it's not created as of now. Little space.
Hmm. Go to the end. Hmm. There is an option called create change set before create stack.
I don't. Not aware with this a change set. I think it must be, like change set is a preview of how this stack will be configured before creating the stack. Okay, how this will be configured. That is what is
This is like a preview.
preview kind of thing. Yeah, but why it's not created? Either we need to create a AWS role access. Is it done for you guys? Means it has created the workspace?
I'm in this.
Uh,
I'm in the same page. So we have to acknowledge and create stack, right?
yeah. Or else you need to check with the lab vendor that what maybe
I progressed to next step, but I think it failed.
it's failing. Maybe they have not given us permission to create certain thing. I need to check with the lab vendor that why they have not given this. No worries. Meanwhile, you all can do one thing before we can do this. Like we will check with the lab vendor and we will resolve this issue. Meanwhile, you do one thing. Just quickly, um, like meanwhile you create your this what we say. Um, where is my
Community edition है.
community edition, and there we can also do that. So this is my community edition account, right? So you need to just log into community.cloud.databricks. Control C.
Yeah, but let's try that. Community edition.
Huh?
Let's try community edition.
Yeah, that's okay. So meanwhile, just log into community.databricks.com, right? And since it will here, if you are new to sign up, it will ask you to sign up. So it will open link in new tab. You need to do one thing. You need to mention details here, right? And you all will have your account here. So from here also we can mount our from AWS, whatever you want to do, you can do everything from here also. Just there are some uh, you know cluster, the high-end cluster you can create in the premium account. That's even we not required. But even though we will have a look. First, you just type your name and everything and all. So I'll show you. You need what there is something that you need to follow me. So do you want me to share this login community.data cloud.database login?
Yeah, we'll be doing that. Yeah.
Yeah. So if you all are here, it will ask you to log in. So let's say I'm just showing you let's say once you mentioned your name and everything, and once you continue this, uh,
Dipesh, could you please share the link
yeah, I'm
of
just
the?
now, once you continue here, there's an option you will get. What option you'll get? Either it will ask you to log in professional use. You can connect the AWS Web Services, Microsoft Azure, or Google Cloud platform. You'll need an admin access to access your cloud account to generate it. From here, you can also do that. And it will again let you go to that page, what you're doing. Or else there is an option, get started with community edition. Can you see that?
Yeah, we need to use the personal use one.
Correct. So it will, for a lifetime, you can actually use it.
I think the workspace is getting created when you create the account through community edition. Have you guys tried it?
Yeah, we know that I was able to create the account actually,
Mm-hmm.
community edition, not the,
Yeah. Are you able to log in?
yeah.
Yeah. I mean, we don't have to create a workspace separately. It's
No,
included.
actually, yeah, there is that option that for personal use one. That option I selected. So at the top there is option where we select the cloud. Either
Hmm.
there is another option for personal use, right? So try the
Yes.
community edition. So when I clicked on that, basically, I got a mail verification email to
Hmm.
my account. And then I verified the account, and then I was able to log.
Yeah. I mean, its login is working. What I'm trying to say is, if
Mhm.
you use cloud option, then you have to create the workspace separately.
Yeah,
But
yeah,
if you use community edition, the workplace is already included.
right. I guess, yeah, means they are using the cloud at the backend, and we don't know which one.
Hmm.
So
Yeah.
Databricks have their own cloud, like they are creating this workspace over there. They have their own 15 GB of memory they are providing us and a cluster. And we don't know
Mm-hmm.
like whether they are using third-party cloud in behind, but they are managing everything.
Mm-hmm.
But if you wanted to use the third-party cloud like AWS, Google or something, then you need to get the cluster done or workspace on that platform. So that is the one. You all are created this?
Yeah, we created community edition.
Community edition we have created.
Maybe. No.
So Dipesh, we should not route it through again the AWS account, right?
No. See, the idea of using AWS is to accessing the data, first of all. So anyways, we can access the data from AWS to S3 by, creating some, IAM access. That's all we can do that. So that's not a big deal. So we will be working on community edition as of now. Okay. And if we wish we will check, just because that is just you helping us to create a cluster on, creating a workspace on the AWS cloud. So whatever resources and everything we have, we would able to use on AWS account. But let's suppose after the training your AWS account has to be, dismissed and all. So every data, every single thing will be for you is going to be vanished. So instead of that, we can use this community edition, and whatever data you want to access from Databricks, sorry, AWS, you can access, mount it here itself. Hold it up.
Anushka, you have to select the next option. Try community edition at the end.
Yeah.
Get started with community edition. I'm clicking on
Yeah.
that
Hmm.
for
You have to,
personal use. I'm when I'm clicking on that one, it's giving error below that one, which I shared in the screenshot.
Yeah, I guess that caption
Even
we solved, right? That
yeah,
caption.
No, I
even
resolved
after
that
that,
one.
yeah, even after that, I am also facing the same. I'm getting this and another error occurred. Please try again later.
Okay.
In that case, maybe just it's a temporary thing, I guess. Maybe
Yeah, just check after on another browser or maybe another or delete the history or something like that. It will work. Because if any number of people can do that, we can also. How you have created the account? Can you type Y in the chat box? Are you using the same link that I have shared with you?
Yes.
Yeah, please mention your details. Okay. In below, there's an option.
Yes. We don't have to select. Do we have to select anything
No,
from here?
nothing. Just get started with community edition. Yeah.
I think we need to use the personal email. What I think is because
Yeah.
personal use.
Yeah, the professional email doesn't work. So you can try with personal email. It does work. I did try and I see that it is now created.
Yeah.
For
Works with personal emails only.
I think we need to validate when we use
Yeah,
our personal email.
You will get an email.
Again, the
might have-
error is
no.
You get a passcode.
no, but
That so you click on that get started with community edition.
I did.
Shraddha,
But
try in Edge by giving your personal email. Should
this
work.
is Edge only. I tried with Chrome. It was throwing me an error, so
Okay.
I'm using Edge.
Yeah, even I was facing same, but then I gave personal email and then it did work for me.
I was able to create with the laptop email only. I verified everything from there.
Okay, then might be something else.
Now, can you click again, Shraddha, to get started with community edition? It's not allowing to go next page.
It will again ask for the same puzzle and error it will throw.
Either browser.
Connected to VPN or something? Or no, right?
VPN is connected.
No, it has nothing to do with VPN. Even I connected to VPN and it worked for me.
Okay. Because these all puzzle and all, it didn't ask for me.
It did ask for me.
We directly allowed to create the account. Just it asks the passcode. So in the email, you will get a passcode that you enter and it will allow you to create.
So what I did was when I was not able to get started with community edition, I clicked on this continue. So I received an email. Is this a community edition email?
No.
No, right?
The one that you have created for premium one, I believe so.
No, that was different. Again, I just.
Then you should click on this.
Get started, you can click.
Yeah. For login to get started, yeah. Just click on this. Nothing happening.
No.
Yeah. It will just allow you to log in. Yeah, just put your email ID. This the mail ID you have given that time?
Last time, yes.
Now it will log in.
No, they don't give here. Shraddha, go to your previous tab. This is because you click multiple times, it is opening.
Verify code over there.
Yeah. Now go to your email and get the code.
I guess this is for the AWS one. It will ask, will have get the AWS account also, and the root access everything.
And it's because maybe you have created an account using the mail ID that you have with this, and then again you are creating an community edition.
Okay, I'll try it out maybe after while the during the call, and we can proceed. I'll try it out from my.
What about others? Like what is the percentage that we are done with this account, community add-on? Can we all quickly type why? I got to know like what is the percentage that's done. My is done, my is done, Repop is done. So, okay. Savishkar. Okay. Ashuri is also done. So almost maximum people are done. Okay. Uh, Good enough. So we are good to proceed then. Right. So this is what my Databricks Community Edition found. Let me just walk you go through this. Yeah. So this is the user interface of Databricks, right? So I need to quickly, before I actually walk you go through about the user interface of Databricks, I need to tell you a few important part of, a bit of, Spark and Databricks and how briefly it can help us for doing another stuff. So let me just quickly do that. Yeah. So if my screen is visible, correct. So my screen is visible to all of you?
Yes.
Yeah.
Yes.
So we have, as of now in this big data, what we have discussed is we have discussed the traditional systems were failing, and that is why we introduced Spark, right? So what was the traditional system were failing? MapReduce was failing, because MapReduce had certain bottleneck that it was a centralized server and it was processing the data, but MapReduce is, speed it not so well and all. So that's why Google has been introduced as MapReduce, right? So the challenges with MapReduce were the data sharing abstraction, inefficient use of resources. Then that's how we got Apache Spark. So when we got Apache Spark, Spark is an open source unified analytics engine, and that is for large scale data processing basically. And it was fast, efficient, and that supports structured and semi-structured and unstructured data, right? So Apache Spark is fast, efficient, and in-memory engine. That's why it was 100 times faster than Hadoop, correct? That we already discussed. Apache Spark was highly scalable architecture, and that is why it is able to process terabytes of data, and it is actually helping us to do parallel processing at the same time. So that is why it was a kind of like a very highly scalable architecture. It unifies varieties of use cases, means it can do batch processing, streaming ingestion, doing machine learning, and advanced analytics as well, right? Whereas Hadoop, when we had Hadoop, have three major things. One is SDFS, Hadoop a distributed file system for managing and storing the data. MapReduce is the framework to define a data processing task. Yarn is the framework to run the data processing task, right? It's kind of a cluster manager between them. That is how it does coordinating. Whereas in Spark having interface we call Spark SQL. Okay, so Spark SQL is the one. Spark SQL is there. Spark Streaming is there. Spark MLib is there. Spark GraphX is there, and this is between there is a Spark core. So Spark core is the base engine, and that allow us to get the all the gateway of Spark functionality, right? And for cluster management, whether we are using Spark core engine or SDFS is the database that we store in the Spark. Yeah. Do you have any question? And the Spark ecosystem?
So basically, it does not replace, it uses existing components of Hadoop.
A distributed file system we are using. Yeah, that's
Hmm.
what we installed in yesterday. If you have seen that, we have installed Hadoop as well, right?
Mhm.
Yeah. So Hadoop distributed file system we are using. We can use a cluster manager like Yarn because that is leveraging this Spark core, cluster manager. And Spark core is having their own way where we have all the Spark functionality. And on the top of it, we are using the Spark SQL, the streaming, Spark machine learning library or graphics.
So basically, this uses Hadoop's storage, but the engine is its own, right?
Yeah, correct.
Mhm.
Instead of MapReduce and other thing, it has their own engine. But the file system is into the SDFS form. That is how the idea of uh, you know uh, distributed file systems. And Apache and Hadoop both are the project of sorry Spark and Hadoop both are the project of Apache. So they can use that ecosystem. Yeah. So again, we have a native support real time as well as batch processing. Um, like, and one thing that is with Spark is since it's working into this environment of Scala, and it's a interactive REPL environment. Okay. So basically, Scala is meant in such a way that Scala REPL is in a such a way that is able to read, evaluate, and print and loop the process. Okay. So Scala has been written and Spark is written in Scala. Okay. So it's kind of a playground area to test the process in Apache Spark. So it's an interactive REPL environment in Apache Spark. This also support Python, Java, Scala, and R. So that is the good thing with the Apache Spark that one can look around it. Now, the most important building block of Apache Spark is nothing but it's their Spark, RDD. So Spark RDD, as I mentioned here, Spark RDD is the fundamental building block of Spark, right? So it's a fundamental building block of Spark, and that is that Spark is actually able to do all the advanced possibility because of their RDD structure. RDD is one of the most important structure of Spark. And why it is one of the most important structure of Spark? Because RDD itself is allowing you to do multiple things, right? So how RDD is allowing us to do multiple things? Let me just tell you here. So basically, RDD, are able to perform two actions. When we write a Spark code, when we write a Spark program, you'll see me that I will show you that how we are able to, like create and define some kind of actions and transformation steps. So RDD is mm, RDD is basically yeah. So if I'm talking about RDD, so RDD having two things, because all memories are in memory, all the Spark performed in memory. So actions and transformation things we are doing. Did we discuss this already, right? So what is actions and what is transformation? Hello? Who gonna tell me? What are the functions in actions and what are the functions in?
Yeah, action is basically execution of some task where a new RDD is not formed because RDD is immutable. While transformation is like when we do some transformation, that means a data transformation, a new RDD is formed whenever we do any operation like join, etc.
Yeah. So what all the functions that in Spark RDD and what are the function in Spark actions? So I believe I have discussed with you that thing. So there are few functions that's come under Spark, transformation, and few functions are there. So like if we talk about the transformation, if you remember, I have discussed in Spark, we can do like map, okay, filter, where we are making a new data frame, or new RDD, you can say join, union, these kind of things we can do that, right? And whereas in action, we can do count, we can do find out the reduce, we can do first, we can find out as I mentioned here. So these are the functions that we are able to do into this RDD by using, this functionalities of RDD. And uh, RDD have their amazing capability. What this amazing capabilities of RDD is that RDD can allow us to do partitioning. It can allow us to do partitioning. So partition can be done. So what is partition of data? If you just wanted to understand the partition of data, let me just have you look here. So when I say RDD is, like can do these things. RDD can do partition, it is immutable in nature and it is resilient. Okay. So these are the characteristics of RDD. And I want all of you, if you are, I will share you this document anyways. If you are making some notes, please write this because that is one of the important, topic that we are discussing. The characteristics of RDD. So the very one is that I mentioned here is one is the partitioning. The partitioning we can do, it's immutable in nature and it is resilient. So what is the meaning of partitioning of data immutable in nature and what is resilient? We will have a look. So here, if I just walk you go through the partition. So partition means, like whenever you have any data, what is that idea? Idea of a distributed architecture is that we can distribute the data into SDFS so that we put the data into different nodes and different clusters are running behind to process the data. So when we are partitioning the data, so partition means this. So we have a cluster, we have a data and we wanted to partition this on certain nodes, so we can do that. Okay. So partition will allow us to do parallel processing. Okay, that is why we do partition. Okay, so parallel processing is what nothing but it's the main reason for splitting the data across multiple nodes. It's called parallelization. So when we create the RDD, we will be also going to create RDD using parallelization. Okay, and data can be processed in parallel in all of the individual nodes. Did you get the point?
Yeah.
Yeah, one question actually, Dipesh here. So
Yeah.
basically, we said the HDFS is basically the at the base where it is a storage of Spark as well, right?
Yeah.
Then the Spark is a processing engine. So in the HDFS, when we say HDFS, it is also distributed file system. So there also the files are distributed across multiple servers or clusters in clusters. And again, while processing as well, if we are getting a file from a particular clusters, those also are parallelized. You are saying here, right? In the RDDs, even
And,
from a single node, if we are getting a file to process, for example, so that processing will also happen in parallel way or parallel manner.
yeah, I mean, parallel processing mean is that we have different nodes, and different nodes are keep running on certain amount of data. The data are stored into in a distributed format, okay, and like distributed formats are there. So when you are running this parallel processing in Spark and all, so it's actually the datas are itself over there, but executors that is executing the task, okay, that getting certain amount of information that these are the tasks has to be done into parallel. Are you getting my point? So that is on the Spark core side, that the executor are executing task in parallel, and the datas are residing in SDFS.
In different systems, but
Correct. In different storage or rack, you can say that.
different racks. But even if no, my question was, even if it is present, the data is present in the same rack. Okay.
Yeah, it will do parallel processing.
Still, it will do parallel
It
processing.
is, it is, it is not just the data parallel processing, rather it is task parallel processing,
Got it.
right? So the task is getting parallelized here.
Okay, the parallel processing feature is basically from the Spark, where like we can say it is happening 2 times here. Then, like
Yeah.
in itself, HDF is also parallel, and then again the Spark tool is also doing a separate bit of parallel processing on it, on the top of it.
You can say that because the data
But
are
I think
ready.
no, I think Maitreya, but I think that is not processing, that's storage as the
That is
HDFS.
storage. That's what I'm supposed to gonna talk. One
Ah.
thing is storage. Means let's suppose you have n number of hard disks where you have keep the data over there. Okay. So those are stored data in somewhere into distributed form, right? But when we talk about the task, like my task is that I want to, like calculate the number of orders been delivered in this region. So I have divided the task into 2 steps, two different data. So now the data will be acquired, but the task that need to be done on the worker node, okay? So the master node has given some instructions on the worker node side, means executor side. Executors are doing the task in parallel processing.
Right.
Yeah.
Right.
We discussed the architecture, I believe so.
So in that architecture only we saw that there is one master and then there are slave
Yeah,
nodes, right? And the slave nodes are nothing but the worker nodes as well, right? And the metadata is stored in the master, right?
We have discussed it. Let me just quickly show you once again if you are not able to recall that.
No, so my just only question was the
Yeah, you are right. I think your point is that one, the data is distributed and the task is also distributed. So yeah, you can say that task is one thing, that is the processing stuff, and
Right.
data is one thing, that is the distributed architecture. So data is stored also in distributed architecture, and you can also do the task in the parallel processing. So these are not so connected, you can say, but yeah, in your sense, like
maybe
yeah,
performance wise it will be better only.
yeah.
Okay.
So that is the idea. Now moving further, this is your partitioning. Once the partitioning is done, then the data is stored in memory for each node in cluster. You can say that the most important thing about Spark is that contains of this RDD are kept entirely in memory across multiple clusters. So here we are not talking about data. We are talking about the process, the processing that keep inside the RAM that's in memory that we are talking. Because you cannot store the data in memory. Data could be in millions of rows. Data could be in high terabytes, right? That you cannot keep in memory, but you can store the task that in memory that will happen. For the point? Yeah. So as I mentioned here, RDD is immutable in nature. Okay. So only 2 types of operations are there. One is transformation and one is actions, right? So transformation is to transform into another RDD. Whereas actions is nothing but it's a request or a result. Okay. When I say RDD is immutable, means you can have a look. RDD is immutable means a data set loaded into RDD like this. So we have first name, that's called Mikey, Pat, Wonder, whatever the data you have. Let's say the user may define a chain of transformation on the data set. Example transformation, first, they wanted to load the data. They pick only third column. Then they want to sort the value. Okay. And these are the examples of transformations. Whereas the actions examples are, they want to first print the 10 rows. or a count or a sum. So these are the examples of RDD in actions and transformation that we are talking. One of the most important part that is in RDD is called a lazy evaluation. Anybody have an idea what the meaning of that? Lazy evaluation. Basically, what is the lazy evaluation of a Spark of RDD, Spark RDD? As I mentioned, that Spark is written into Scala, right? And Scala also has this lazy evaluation process. What is lazy evaluation? Basically, RDD keep record the series of transformation that has been requested by the user. Let's say I have requested to do the transformation or print something or do a join or something. All the records are being with the stepwise have been mentioned inside RDD. So RDD keep a record of the series of transformation requested by the user. So it groups the transformation in efficient way that when an action is being requested, okay, when an action is being requested, that like going to be like will print rather than creating a new RDD. Okay, so that is helping us to reduce the like transformation steps for actions results, right? So that's how transform the RDD to create a new RDD. The transformation, whenever it is happening, it is creating a new RDD. Whereas action, reading the data, that's in lazy evaluation from the RDD. Got the point? Hello?
Yeah, Deepesh, can you explain that again?
Just a second now.
And is it possible to give an example like how it happens?
Yeah, right. Example. Yeah.
See, understand one thing. Let's suppose, okay. So let's suppose if yes. So let's say you have, like when you are creating a new RDD, okay. So here, let's say you are doing parallelize in RDD. Okay, when you're doing parallelize in RDD. So when you are doing parallelize of printing in RDD, you created an RDD. So you are doing a parallel connection. So parallel collection, okay, RDD 14. Okay. So it's a parallelize command. So it created a new RDD called RDD 14. Okay. So I will show you in a DAG scheduler basically that what is the meaning of that. Now let's say on the top of it, you created a map task. So when you created a map task, you will see that the RDD 15 has been created. Okay. A new RDD has been created. Okay. When you do a map task, when you do kind of like another set of process, it will create a new RDD. Whereas like since RDDs are creating from the series of transformation, so here we have RDD, another RDD here, another RDD, another RDD. Why these RDDs are a step into this? Because these are lineage in nature. Lineage in nature. Lineage in nature means what? It know from which RDD1 it has created. Let's say I'm again creating a new step. So what it will do, it will create a new RDD, but it's know, let's say it's RDD 18, but it's know that I have been created from RDD 15. Are you getting my point? So this is lineage in nature. This no, I have created from this RDD. This no, I have created from this RDD. Okay, means it's keep the record. It keep the record from where it has been created. It's been created. So that is the meaning of lazy evaluation. In lazy evaluation, the property of RDD is lineage. Okay, when I say lineage, lineage means this. So RDD is lineage. It able to understand from where it has been created, from which RDD I am getting created. It's let's say RDD 1, 2. Okay, the name of this RDD is let's say called 7. So it's no, I have been created from RDD 2. Okay, and that's how my record is there. Okay, so Spark keep a record of series of transformation requested by user. So RDD can be created in two ways: by reading a file or transforming into another RDD. and every RDD keep track of where it came from. So the lazy transformation means the lazy evaluation means since RDD have a feature of record where it came from. So whenever any action is being requested, it will directly print the output from the created RDD. Created RDD. Did you get my point? It just actions are reading a data. Hello.
Yeah, Dipesh.
Yeah. So like this just an stuff. So basically, basically when you have multiple RDDs, what I'm talking about, multiple RDDs are here. So this is the parent RDD. This is the parent RDD. Can I just create in a better way? What can I do? Yeah. So let's suppose we have something called a parent RDD. So these are your parent RDD. Okay, these are your parent RDD. From this is the parent RDD. It's a parent RDD. And since as I mentioned, it's a lineage in nature. It's lineage in nature. So whenever let's say a transformation is being requested, let's suppose a transformation is being requested. So a transformation will happen, and since this is the transformation we are doing. Okay, so whatever functions like map, flat map, okay, these are there. So it will create a new RDD. Means it's been transformation happen. It will again going to create a new RDD here. It will add a new RDD, right? But whereas if any action is being requested, so action results will just create just an action value. Okay, and it will show the results. So means if any transformation will happen, it will add a new RDD and this know like I have been created from this. I've been created from this. I've been created from this. I've been created from this. But whereas action just going to print the results.
Dipesh, the action is going to perform on the latest RDD, right?
Yeah.
Then what is the use of tracking the old RDDs?
What is the use of tracking old RDD? Because one RDD is creating from the previous RDD. Okay.
Correct.
The previous RDD, since reduce the steps. Okay, the previous RDD reduce the steps. Like let's say we have a join. So that join is came from the another join. So let's say if you are creating into certain a brand new RDD, if you are creating okay on a new data set, again there is a no sequence of that. But if it is creating from the previous RDD, this know what are the steps has been followed. So whenever any action results need to be there, this action results can be printed. So that is why we keep the record for the lazy evaluation.
But the action is always performed on the latest RDD. This is correct?
No, it's not like that. Let's suppose you are doing some task and you wanted to recall the previous RDD. You can just recall it, no? You can see the results of the previous RDD also. Until unless you don't have any objective that to create a new RDD, why would you create a new RDD?
No, every transformation you're saying a new RDD will be created from the previous version.
So if you are doing any transformation, okay, so whenever you're doing any transformation, so it triggered a certain, like set of new RDD. So, any transformation occurs, then this considered as kind of a, to create a new RDD because RDD by nature is a immutable, right? So you cannot update the value. Okay. But since you cannot update the value, you are resulting to create a new RDD, but it knows from where it has been created, which steps that is mentioned on the top of it that has been created to.
Yeah, yeah, understand that part. But what I'm trying to understand is how this maintaining the track of this chain of RDDs is going to help in execution.
Mhm.
Because the action that you are going to perform will always be applied on the latest RDD.
Yeah, yeah,
Then,
yeah.
then,
We can see
then what is the
that we can see from the DAG that how it has been performed, which RDD is. So everything is in a DAG is mentioned. So the DAG visualizer will be there, and from the DAG you can see from this RDD we have created, from this it has been created. So that's how you'll have an idea.
How it is helping in lazy evaluation.
yeah
How it is?
helping in lazy evaluation?
What?
Basically, we understand the concept.
Uh,
So basically, let's say we read data from a file, so it will create an RDD. On
mhm.
top of that file, we applied some transformations that will result in another RDD. Now you have two
That is the
RDDs.
feature. That is the feature I'm telling you of RDD. Lazy evaluation is one of the feature. It is not helping us to create a new RDD. RDD itself is a feature of lazy evaluation.
Correct. We are trying to understand how it is being what is the benefit of that creating that older version and the newer version?
What is the
How it
benefit
is
of
helping execution?
Why would you not create? Let's say you wanted to join, two things, and then again you have another join. So we are not creating a different RDD just because we want that to create newer version. Are you getting my point? This is not about that thing. This is about your requirement. When you are doing some analysis task or when you are doing ETL job, you have to perform certain things. So first you have imported the data. Okay. Let's say you have a huge ingestion of data. So that ingestion of data you imported and you wanted to print the data from it. So this is your first data. I mean, this is the first, let's say you have, this is the entry of RDD, which have keep the record of all the data. This is all the data. Now, once you have
Hmm.
all the data, just you wanted to create the separate these two columns,
Hmm.
where you're going to perform. So this keep the record that these two columns have been created from this RDD1.
Okay.
Yeah, this is the meaning of creating a new RDD from the previous RDD. Or let's say you wanted to join these two column based on some certain group by. So this allow you to result to create a new RDD.
Yeah, that's correct. So basically, you said lazy evaluation is a technique or the feature in Databricks, right? Where
Uh-huh.
or Apache Spark, where basically it keeps the track of all the transformations,
Uh,
and when in case of actions, basically, yeah, it uses that feature, right?
correct.
If any action is to be executed, right? So
Yes.
the question is basically, for example, as you see, the first load of data in an RDD,
Uh-huh.
there are 10 columns and 1000 rows. Okay.
Uh,
The data, like RDD1 is created. Then the second RDD is basically where there are two columns and 10,000 rows only.
mm,
So there is a second RDD created. And now third is basically the action. I need to print something out of that. Okay.
mm,
Or I need to sum up something, some
mm,
aggregation, right?
uh,
So that is the action, right?
correct.
So how lazy evaluation is helping in all this stuff? That is the question. Why basically that feature is there?
Easy evaluation is helping into the process because let's suppose, while you have did a transformation, you have created an RDD, right? Sorry, when you are creating, when you have created an RDD, let's suppose, but now you want to do count, okay? So in while forming a RDD, okay, while forming an RDD, there are series of transformation has been done. Okay. Um, so when you are just printing or you are just doing a count, so lazy evaluation concept that's in a functional process that we are using, it's optimize the execution of program by reducing the computational load. Okay. So lazy evaluation is not going to do the task again to help us to get the output. Rather, it have some certain information in RDD itself, and efficiently it will print count for you because the steps were mentioned that how the transformation has happened. It has certain form of stages inside this. Some task has been done inside this. So those information will be kept from there and it will allow you to print this. That is how it will help you. Did you get my point?
Yeah, bitter got actually.
So is lazy evaluation is enhancing the performance. How? Because it does not letting do the task again and again or to print the action results. Rather, it is taking the steps of the transformation that is already done, and like it able to get the output from this process and allow us to print or give the from their output input output disk memory, give those stuff and print the output for us. So that is the meaning of
Somehow lazy evaluation feature is making the use of the history of transformations and just speeding up the process. We can say
correct.
that.
That's what.
Yeah, also here, what happens is like when action is called, maybe there are 100 RDDs are there and one action is called. In between, like action means what we want and transformation can be different. Like we are doing some group by any transformation in between, and what we want is we are printing the count and you don't have to group by. So everything will be kept as a lazy means it won't execute. It will just keep a track like whatever is happening and in the end what we want. Based on that, it will run a query optimizer and that is based on cost based model. I think, yeah, cost based model. And using that, it will create a plan.
That's what I'm supposed to gonna come. See, let's say, please understand one thing. Whenever you request you know, a kind of any transformations or actions, it does not immediately start working. Rather, what Spark do, I'll just quickly type down here. This will give you a better idea.
So I think it just keep tracks of the transformations in series, and they don't really get executed. But when there is an action, then these gets executed. Is that right, Dipesh?
Please allow me 1 second now.
All get won't execute it. First, it will create a creating
Plan. That's what I'm trying to tell you. First, it will
Ah.
create a plan rather than start working directly. So just allow me 1 second because it is something that you all have to understand. Then it is best way to proceed.
One question here. So if there are two actions, right, Dipesh or Nikhil, if there are two actions, then how it will work? Still, it will first create a plan
That
for.
we will see that while working on it. You can see from the DAG. First, please understand the process. So let me just quickly tell you the process that has happened. So whenever you instead see what happened, please understand. Whenever we perform any operations on RDD, data frame, data set, such as you are doing filtering or mapping. So Spark does not immediately process the data to produce the result. Okay, please understand this. That's why I told you when I was telling you the in detail architecture of Spark, I have told you, please look into this. This is quite important. So what we generally do, whenever we perform and whenever any action has to be do, it's build a logical order of DAG. Okay, that's called directed acyclic graph. Directed, where is that? Yeah, it's created directed acyclic graph. Okay, this directed acyclic graph having nothing but it's have a series of transformation that need to be done, series of actions that need to be done. So it's create the form of stages. It's create the form of stages. Okay, those stages once decided, then it proceeds the result that these are the tasks need to be happen. So in order to do the task, there are some certain RDD that is already done. So it will take the data from those RDD and or where the action is where and learn a lazy evaluation to check the history and do the process task accordingly. I believe you got the idea now.
Yeah, I think it is trying to find out a shortcut based on the existing information what the action is
Correct, correct,
instead of starting from the scratch.
correct. It's instead of starting from the scratch, it's just try to create the complete DAG, and that
Hmm.
DAG predict or with the help of various process, like evaluation, it's enhance the performance of the plan by applying optimization, pushing down, multiple thing in behind it's happening. So that's how it's
Got
taken.
it.
So Dipesh, I'm just trying to relate this with any one of the data pipeline, if you think of, right? So in a data pipeline, we will be having n number of transformations. Maybe you want to first sort it and then join it and then filter it,
Hmm.
right? So majority of the transformations, if you think of. So how does this work?
Okay,
Um,
you know about map reduce?
yeah, fair bit of.
A fair bit of. Oh, how map reduce work? MapReduce work like there is first it map the data, then they shuffle the data,
Mhm.
then they first they tokenize the data, then they shuffle the data, then they kind of after shuffling they do matching something like this, and then they reduce the data, and that's how we got output. So just to get a join, these 4 or 5 steps are happening behind that. Are you getting
Mm,
my point?
mm.
What these 4 or 5 steps? These are the stages in this behind inside this. There are some certain tasks need to be happen. Are you getting my point?
Okay.
So whenever you're making any small join or anything, behind this there are form of stages has to be happened. First, it has to be taken some data. So the data, instead of creating a new RDD, it will take that data from the previous RDD.
Mhm.
Once it takes the data from the previous RDD, then it will just apply, need to do tokenize. So it will check whether the tokenization need required or not, if it has happened before or not, if we can take this from this step or not. So these kind of thing happen behind that.
Mhm.
That is the
Okay,
idea.
which is in series and which is
Correct.
uh, already available. It will just make use of the one.
Correct.
Okay, so it directly doesn't execute, but rather it will find
The
and then.
DAG of the series of transformation need to be done in order to process the
Mm,
task. So it's create the stages.
okay.
Yeah,
It
that it will run the optimization model. Let's say like we are doing we are selecting few columns, we are doing filtering, and after
Mm,
that selecting. So in MapReduce, it won't do, means it will do whatever we coded. It won't
mm,
do optimization. But in Spark, it will again it will get optimized. Means whatever first it will do select, after that it will apply filter. Like if
mm,
we do optimization properly, but still Spark can up to some level Spark can do optimizations, and it won't load complete data into memory. And after select, it will do first select. After that, it will do filter. It will interchange the transformation steps also. Yeah.
okay. Okay.
So, like, if you are able to recall or not, let me just quickly reiterate you. So, like when I told you, that how this happened. So, whenever we create, so first of all, whenever you create an RDD object, so RDD object created from multiple RDDs. So, let's say this is your RDD, this is your RDD. From this RDD, multiple RDDs has been created. So, how it is being done? Let's say you're doing RDD one dot join with RDD2. You are joining two different RDDs. Are you getting my point? You are doing
Mm,
group by, and you are doing then filter also. So this is the task you are doing, let's suppose, right? So you build operator of that. So the very first thing will happen, it will build in order to perform this task where it has to join group by and filter. These are the tasks need to be done. So when you build, okay, operator of that, so, it will create a scheduling of DAG. So the DAG scheduler here, DAG is the scheduler. It will create a stages of DAG here that how it has to be done. So it will create the stages of DAG that these are the stages into this. These are the
mm,
stages has to be into this. Okay. And that's how it will coordinate certain thing. It has to be coordinate with certain amount of other form of task of stages and then it will generate an output of task that we need to do this. So these are the task set that need to be defined here. So these are nothing but it's a task set. Task set. So basically, what DAG is doing for us, this is split the graph into stages of task and submit each stages as ready. Okay. So, and one thing you also need to understand. Okay. So, like, once this is done, this task set, where this task set will be done. So, these are from the master node side. This is nothing but it's a master node, or you can say that a Spark core program. Spark, it's a master node. You can say that. Okay. So in the master node, it is happening. Now on the worker node side, there is a worker node. So worker node side, the task has to be given to the executor. So executor is the one, there is the executor will happen. Executor is there. So executor having all the threads, how this is getting executed and the block manager, okay, where all the stuffs are there. And this task has to be given using a cluster manager, a cluster managers. Okay, this launch task via cluster manager and retrieve, failed, straggling, whatever you say. So this is how the stacks happen. Okay, and how it is happened, I have already discussed with you that there is a complete process. In this complete process, like if I just create a new, did you understood this thing?
Yeah. Yeah.
Yeah, just a new one. So how this happens, so whenever you have written the program, this was your program. So whatever the program you have written, so how the driver, master driver is there, how driver is working. First, it is creating an RDD graph. Okay. Then a DAG scheduler. Okay. Then there is a task scheduler. Then a scheduler backend. Okay. Here is your cluster manager. Okay. And this is your executor. Yeah, this is your executor. So this is how the process of driver program work. Okay, this is the high level architecture if you want to understand. Okay, and the low level architecture if you want to understood of Spark, as if you remember or not. So there was a driver program. This driver program. This is the driver program. There was a driver program. In this, there is a functionality of Spark context is there. Spark context is there. There is a cluster manager. Okay, and this cluster manager further coordinate with multiple nodes. Node 1, node 2, and node n. And there are multiple executors having multiple tasks. Task. So this is the architecture. I believe now it's clear, right? Is it so? Okay. Good enough. So this is the some basic understanding of Spark. Now the next I will be discussing the user interface of. So I have discussed this thing. Just a second. Let me just work. I was just talking about this resilient and all. So further we will be discussing further how the data frame and other stuff in there, the web UI or database. So you can go for a break and then we'll come back and discuss further. Any questions that we discuss here?
No, Deepesh.
Nikhil shared one image. So that is how basically the RDDs are developed or
Yeah.
created.
Yes.
This is what I told, right? Yeah, this is what I discussed, correct? Like in which there is a logical plan because need to be created, and then there is some optimized rule. Then yeah, with the
So
help of
all these are kind of behind the scenes, or
behind the scene, yeah, behind the scene. For you are just writing a program, but you should know like like how it is working.
okay.
So let's say like we have the data frame, means like we are writing any transformation logic. Okay. And first what it will do is like whatever logic it was written, that is unresolved logical plan, means that is not resolved. Later it will get the schema details, means like whatever the source schema we will give, right? So it will get the schema details. And after that it will map, means what are the column names we have mentioned in the filter or in any transformation or action. So everything is correct. So after that, it will create a logical plan. If here schema mismatch detected, here only it will throw error. It won't go further onwards. And after that, it will create a logical plan and it will run through Catalyst Optimizer here. So in this optimization stage, what happens is like if you have any repeated actions and if like order is not correct and previous RDD also it can take information if it is already there. It can take info and it can create an optimized logical plan. So this optimized logical plan, if you already like previously we cached or something, right? Everything will be used here, and based on that, it will create an optimized logical plans. And using there will be multiple optimized logical plan it will create. Using that, it will only select the one optimized plan based on the optimizer. That is a catalyst cost-based optimizer it will use, and it will whatever physical plan logical plan is selected, it will convert into actual code. This physical plan contains actually uh, okay physical plans, it okay using the logical plans it will create multiple physical plans also. So later it will run cost based optimizer. I think I did but it cost based optimizer will run after physical plan, sorry. And later selected physical plan will get
So
converted.
what is that physical plan about? It's about the resources, how much it is needed to execute, or the transformations. Like, what is this physical plan? Yes.
Like logical plan, actually what will happen, like whatever we send the code, right? It will just create a plan, means this can be done. Okay, it will create a structure. And after that, physical plan is actually getting executed. This physical plan, we can add code gen is equal to true after that, so that we can get the Java code. These physical plans will be actually Java code. But logical
compiled code, is it? Like which can be compiled on a PC. Like,
sorry?
it will be a computer code, the physical plan which you are saying.
Yeah.
Physical plan is, oh, sorry, the logical plan, I believe you guys understood, right? Logical plan refers to an abstract of all the transformation steps that need to be executed, right? Correct? So that is the logical plan. So once the logical plan has been done, then kind of a semantic understanding is there, that this need to be there. Then the physical plan need to be done. So physical plan is nothing but it's an encashment, internal encashment that is being done. So internal encashment, or you can say that optimization of Spark, it's generated after creation of all the optimized logical plan that we had. So let's say, in example, if I say, let's say you are joining query between two tables. So in that join operation, one of them is a large table and the another one is a small table with a different number of partition, you know, is scattered in different nodes across the cluster. So it can be in a single rack or different rack also. So this physical plan is helping you to decide which partition should be joined at the start, order of joining, the type of join, etc. for better optimization. So it's limited to Spark operation only. Got the point?
So again, out of those many physical plans, only the after the cost model, we have the selected physical plan. So which means that there will be also many physical plants available there, or out of which?
We will talk when we'll come on the optimization phase and all, then we'll discuss these things.
Yeah, there will be physical plans will get created.
We'll discuss those stuff. That's not a problem. Later on, we'll discuss. We cannot discuss in beginning.
Okay.
Yeah.
Yeah, we can see it now.
So this is how a data frame look like, you know. So RDD, we can create RDD, and RDD was into the initial version, and then RDD has, you know, Spark has introduced data frame also. So a data frame actually look like the pandas data frame. Can you see that? So we have this like similar like pandas or data frame. Similarly, this data frame is there. Also in Spark, this data set is also there, but data set is primarily used with Java, Scala, those kind of languages. Okay, this support, you know, this data set support primarily Scala and Java only. So this is being supported by Java and Scala only and Scala. So that's why we don't talk about data set. We talk about data frame and RDD. So RDD we have already discussed. So data frame and the RDD data set has been taken from RDD only, but the user interface is better. The structured one, you have a collection of rows and columns. So primary abstractions in initial version, it's an immutable and distributed, a strong typing use of lambda, no optimized execution, available in all languages. Also immutable and distributed, same, everything. So it is present in Scala, Java, Python, R, everything it supports. It does it. Uh, you know, this data frame, sorry, available in all languages, right? Not, but data set is not available in all Python and R. So this is available, data frame is available in all of them. Yeah. So this is how, you know, like in Spark 2.0, you know, second version, this data frame has been assimilated. Okay. So data frame is little better. You know, you have a data set rows and columns structured are there. That's why data frame are more popular. Okay. And whereas if somebody is from Scala and Java, then they can look around, you know, because it's data set and RDD is just only collection of data, you know, some values over there. That's how you can use that. Any questions around this?
Can you differentiate data set and data frame using an example? Let's say there is a table. We select a query on one of the columns using a filter. What is the data frame and what is the data set?
See, when we talk about data frame, you know, so data frame have rows and columns, right?
Right.
So, you know, when you're writing, you know, like you are just writing a data set, okay? So data set is having all the features like similarly already have, and you wanted to write and, you know, like a sequence of data frame. So data frame have a rows and column values over there. Whereas, you know, like when you're calling, you know, a data set, you know, so let's say you are importing a Spark session, you have builder app name, then data set, something like you have given. So you will import some kind of a, you know, like the in PySpark you don't do it using Java, you will do that. In Java or Scala, there is a process of collecting the values. Okay, so those collections elements will be taken up that way, and you know that's you need to define a specific role. But the features, the usual use, you know, the user interface is not exactly as the data frame do have. So whereas, you know, like let's say, you know, when we are using, we are creating, you have taken an example like you have a data frame you have created with rows and columns. So let's say I have a rows and column, let's say called people. Okay, so in people, I wanted to, we are creating with, we have some person, let's say called John and then Jan, do whatever you have, right? You can convert into the data frame, you know, but if you are converting into the data set, you know, let's say, you know, you are creating, let's say, sequence of John 30, John 25 age, something like that you are taking. So that is a data set. So, you know, the difference, what is happening when you created that data frame, you know, that's compiled be like a functional programming. It's construct like a map process. It will not display the exact rows and column over there to you. Whereas in data frame, it will able to give you a better output, and the visualization is better. But that have their own functionality. Data set have much functionality. I have not even explored much on data set. Data frame is something that is very similar to like the pandas data frames and all. So that's it.
Data frames I can visualize. It's like a part of your table having columns and rows. But data set is something I'm struggling to visualize how it would look like.
See, data frame you can
Dipesh?
visualize, I can understand. So data set is like, let's say you create a sequence of values rather than in this you created a columns and rows. You create a sequence of values of same values. Let's say you have some values, let's say called lab corp, or we have 10 people. You are creating a data sequence of elements of 10 people with their dictionaries of values in Java, let's say in Scala. So you need to understand how Scala is writing the code. So Scala writing, let's say you have a sequence of values, you have a sequence of values, lab corp, XYZ, age is 30, lab corp, Jane, age is 20, like this. So this is how you convert this. Okay. And so once you convert this into data show, you will able to visualize that. I'll show you. I'll write a small program later on. Then I'll show you how does it actually look like.
And based on your example, data set is similar to set, where the collection of related values are there.
Based on
Data set is nothing but a set. We have this set, right?
data set is just nothing but it's a set of
Nothing but a set
elements.
of values.
Correct. Set of elements. Yeah.
Yeah, we can use for each map, for each function, for each print line function to see all the dataset values. And dataset, I used dataset before. The dataset is compile type safety. That is the main feature. Let's say like if you are pointing to wrong columns, I used IntelliJ. And if I point to wrong columns, there will be encoders, type safety encoders will use inside Scala. And if any, say like, let's say like I have created the object data set with some columns, but I'm referring pointing to the wrong column. Then in IntelliJ only I'll get the error. Before executing the code, I'll get the error on the IntelliJ. It was wrong. It will show in the red line. And in data frames, if we give wrong column names, it won't do. Like till after executing only, it will say this column is not identified. That is the feature identifier.
Okay.
And since it's written in Scala, Scala is more optimized also, right?
A data set little bit slower performs compared to
Yeah,
data.
correct.
Yeah, but actually it is type safe, but because of type safety, it will add additional overhead on the Spark. So it will do little bit slow down the performance.
Correct.
Nikhil, while you were working with dataset, what was the language that you used?
Sorry?
While working with datasets, what was the language that you used? Was it
Longest.
Scala? Language. Is it Scala or Java?
So actually, if we have, I used Scala for complex JSON, it was around too much nested JSON, and PySpark we are not able to handle. We wanted to handle that dynamically. Okay, we not able to handle with PySpark. So we went to the dataset and Scala we were able to handle. We can pass outside, we can pass outside in the configuration. What are the columns? How it is like there, and inside that we are able to create the class classes dynamically, and we are using that inside the encoders. So the dynamic is we created using dataset, and dataset like gives more features than data frames. Data frames on top, like it was just a Python API for Spark. Whatever it was giving, we can use that. But dataset we can do more. Either using RDD also we can use, but dataset is more preferred because it will give type safety features, and we can use encoders directly. In RDD, we have to create it. We have to logic writing is too complex.
Okay, thank you.
Definitely. Okay, so this is what about some basics, like about the in detail architecture understanding, and like what is the use of Spark, like how Spark is there, right? Now, moving further, we are supposed to going to talk about the tool on which we are supposed to gonna work. So as I mentioned over there, like I have shown you open up a Spark user interface. I've shown you the Spark, web UI also. Not discuss much, but we will be discussing here. So what make Apache Spark difficult to use sometimes? Because not Apache Spark is even though very manageable than Hadoop, but even though there are some difficulties, what are the difficulties are there? Let's say when you're working into a big environment, okay, so the environment infrastructure management is little hectic because someone who is very good with Linux, everything, you need to have a very well structured way of managing the infrastructure. Upgrade challenge, if you want to upgrade everything, their upgradation is a bigger challenge. Then again, the user interface, like on Jupyter Notebook, I have installed. If I've not would have installed the Jupyter Notebook, I need to write into the command prompt the all the program, okay, and that's how it will able to communicate. But the user interface again, even user interface cluster management, as I mentioned, manual configuration, tooling and integration complexity is very high. And the very bigger problem is since we are doing parallel processing in multiple things, difficult to collaborate on projects. Multiple people cannot collaborate. And because Apache Spark, we want to leverage the capability that n number of people can use it, but that we were not able to do that. So that's why Databricks come into the picture. So did you understand why we require Databricks for Spark? Because we will able to solve the problem of infrastructure management, upgradation challenge, user interface, manual configuration, tooling and integration complexity, difficult collaborates and projects. So these are the challenges we were facing. That's why Databricks come into the picture. Databricks having an efficient and interactive platform. Multiple tools are available. Multiple integrated interactive workspaces can be done. User interface can manage infrastructure and scale failure recovery upgrades. These all things can be done on Databricks, right? So Databricks is nothing but it's a distributed processing of data in memory language support. It support Scala, Python, SQL, R, and Java. You can use the Databricks for batch and stream processing. You can use for machine learning. You can use for advanced analytics. So, and Apache Spark, it's an Apache Spark based unified analytics platform optimized for the clouds. Yeah. So this is what a Databricks. Also, Databricks, if we talk about um, infrastructure management, you can do means you can set up Scala and optimize Apache Spark environment. You can do collaboration. You can do multiple collaboration. For data engineer, data scientists can collaborate, business analysts can collaborate here. Automation can be done on the top of it, advanced automation. You can run data pipelines and workflows and then demand or and schedule these things. You can do run data pipelines, multiple things you can do that here. Security built in across control and enterprise grade security is there. So security is also the one major stuff that you can look around it. Security is high end, right? So, this is what about the basics of Databricks. Now, the big discussion on Azure Database, that's not required because we're not working around. But yeah, let's talk about this in this, when we talk about the Databricks cluster, that is something we're going to discuss. So Databricks have two types of cluster. One is interactive cluster and one is job cluster. Okay. So interactive cluster, multiple users interactively analyze the data together. So let's suppose if we might be using the premium account of Databricks, there we could have created the interactive cluster. Okay, there would be we will have an interactive cluster. So interactive cluster is nothing but kind of a interactively multiple people can interact by creating multiple cluster over there. Job cluster created and terminated for running automated jobs. So when we create an automated job, so that is being created by the program as a job cluster over there. So we have two types of cluster. One is interactive cluster, one is job cluster. Interactive cluster analyze the data and job cluster run automated jobs. So let's say you have made an automated jobs. Okay. So that is will be done by job cluster. This being created by a user, you can create your own job cluster and this being auto created by jobs when it starts. Are you getting my point?
It's kind of an autopilot mode.
Correct. It's a manual terminate and terminate when the job ends. Option to auto terminate if inactive, option to auto terminate not applicable. It's when only will be run when the execution happen. Low execution time, high throughput, how to scaling. These are the. Now, when you talk about in Databricks, in Databricks, you have two types of cluster. Not just two types, there could be more than now they have high concurrency also. We have a standard mode when like the one that is standard mode in data, community version has been taken up, that a single user can use it. Let's say you are running a job, so you will be only, let's say an organization is there, they wanted to run 2, 3 different notebooks of ETL. So then they will use high concurrency mode. So multiple users are using the different jobs over there. Multiple user can use it. Whereas in standard mode, a single ETL job will running at the same time. No fault isolation. Fault isolation is there. No preemption, task preemption, fair resourcing sharing. Each user requires separate cluster, supports Scala and all, only support Python, SQL and R. Okay. So high concurrency modes are on Python, SQL and R.
Dipesh, what is fault isolation?
Fault isolation.
See, cannot on fault isolation. I mean, I believe so. It is related to. Not sure right now. Yeah, I believe it is resource management when we allocate it. Okay, so what happened when in standard modes when we are like in behind this there is sandboxing happen, right? So whenever the sandboxing of the driver process, so that time this it is something, I think the isolations between we can isolate that particular thing. So that is related to the fault isolation. I need to check and let you come back in detail about the fault isolation process of Databricks in a standard mode and high concurrency mode.
And this interactive cluster comes under high concurrency mode.
So when do we kind of configure this standard or high concurrency mode?
When do we configure in standard? See, standard, it's easily to understand. Like, see, standard mode is what? Let's say you are a single user, okay, and you have a certain capability you want for your ETL job, okay. Let's say you don't want to run 3, 4, 5 different other notebooks or ETL jobs at the same times. So you wanted to use a single, a standard mode only. So then you will use this standard modes here. So standard modes having only single, work in in workspace, you can run at a single cluster at a single time. Are you getting my point? Single cluster can be run. Whereas in high concurrency mode, you can run multiple clusters. Multiple clusters can be run parallelly. So let's say I am working on data ingestion from on either resources and doing ETL. My team members are running on either resources and getting those stuff, and we all are ingesting the data from different locations, and then we are putting into the data warehouse. So that's how we use concurrency mode in that.
So mostly it will be concurrency mode all the time. I'm just thinking because if we have to set it up in that way.
In your organization, let's say of course, you can use instead of taking one single account of standard mode rather than high concurrency mode, in which you can, when you opt for high concurrency mode, you can create multiple clusters. So yeah, I mean, for your requirement, an organization requirement, high concurrency mode is required.
I basically you will use a standard mode. Like what happens, it will become a sequence. Means like maybe two people are working parallelly. Okay, means one and other will get swapped. This is just a threading concept. And most of our work development activities can be done in standard mode, because high concurrency mode will use very rarely if our whatever we are executing and maybe 4 or 5 people are writing the code and complex logic, and if it like, they're slow, they feel like their development is affecting and it was getting slowed because of execution, then we can go with high concurrency mode, and high concurrency mode is costlier. And standard
Yeah, it is costlier. It is
always,
very costlier.
if we are not able to use, then only we have to go to high concurrency mode. Not directly selecting high concurrency mode is very costlier. If you one user is maybe two user is using and we are using high concurrency mode, then it will be cluster utilization will be around 5% maybe or 10%. It won't go more beyond.
So, Nikhil, in a team of 5, each user can work on a standard mode. That's possible.
Yeah. Standard mode works, yeah. And if we feel performance is very slow, okay, and we have to write global temporary view, something we'll write. Maybe two people are writing same global temporary view. In standard mode, like each global temp you can access, but in high concurrency mode, everything will get isolated. So like basically we should use standard mode for the organization. And if we feel like any performance issues are there, and if any one workload is affecting other, then we have to go with high concurrency mode.
In that way, even though multiple users are using it, doesn't affect or impact.
Yeah, actually, there is a two concept: interactive cluster and job cluster. Interactive cluster we can use multiple user can use, right? Yeah.
So basically, an interactive one is it's like the cluster that you are interacting for the creating cluster, and that's how interaction will happen.
Cluster,
Yeah.
notebook, yes, yeah. Job cluster is right.
Job cluster is around the jobs when the jobs has been submitted accordingly.
Yeah. But standard mode is single user one. The first point is single.
Yes. The one that we are using is standard mode right now in our in the community version. So standard mode is basically, when we use the standard mode, okay, so like, there is not so scope of multiple people. Well, you are saying, Nikhil, that multiple people can use it, right, in standard mode?
Let me just check one minute. I'm just checking.
It is not like that. So in standard mode, whenever you're using a standard mode, the cluster is only good for single user, not for multiple people. You wanted to use multiple people, then you have to go to the high concurrency mode.
Actually, I can see another option, which is access mode as a single user and shared. So that will define, right? Like which
Shared is nothing, but it's again you are using the cluster only. Then when it's not working, when you are not owning, so it's mean like only single cluster is running at that time.
So can you help me with one thing? Like, let me share my screen. Because I'm getting a little bit confused here. I have the other Databricks workspace. Okay. And here I have already one compute has been created. Okay, someone. And this is a shared, means we are using this one. Okay. And here, let me go to the edit. So here we are using shared, right? This shared cluster will give access to the all. And now, you are saying standard, right? Where is that standard?
No. When you go into the premium one, this is a premium account?
Yeah, premium.
Okay, go into this compute here and compute itself, right? So while you're creating a cluster, there's an option where you want to use the single mode cluster in the compute itself. No, in the compute.
If you go back there, I saw that multi-node and single node. The policy there, multi-node and single node, is that? Scroll up.
Okay.
This one.
This personal compute is single user. Shared compute is multiple users can use. But I'm just thinking about standard and.
So when there is it will come into the cluster mode. Where is your cluster mode?
So we have this concept, right? Single user or it was
You are
shared?
this is the access mode, rather, when while you're creating your compute, there you choose whether you want to have a high concurrency mode, standard, or single node cluster. That's how you will get over there. So you go on compute, create a new compute. There you will able to select it.
You can't create, but okay.
This is how. So basically, this is the cluster modes that I'm talking. Pardon for this. This is the deployment modes. High concurrency, single node, and standards are available in ADF, ADB, Azure
Single
Database.
node. Okay, I have doubt here. Single node means standalone. We have one driver and worker will be running in same. And standard, we have like one driver and maybe some limited amount of clusters will be there. In high concurrency, we have multiple standard clusters, right? Am I correct? So now in standard, why two user can't run?
In standard.
Yeah.
No, standard mode Databricks is when it's allowing us for one cluster can be run. So that is what this intend to be, and this standard mode is applicable in Azure Databricks.
Okay, this high concurrency is a new feature of Databricks, right? The standard mode was
In ADF, in ADF,
okay.
not into the normal Azure and Databricks.
Okay, because we use that, but we don't have this option. And I
Yeah.
remember previously I selected standard and we were able to access, group of people were able to access. I'm little bit, that's why I got confused.
Yeah.
I think standard seems to be a shared node.
No.
But then for the single node we have, right? This is a single node which can be used for.
See, standard one is the, like single node is for just running a single cell at a time, single notebook at a time, single node cluster.
Okay.
Yeah. And, like when you are the standard one is also managing, like, see, what I have told you now, high concurrency standard, single node is for everywhere, but these high concurrency and standards are available into Azure Databricks, not into the normal one. So if you go to the normal Databricks, so there, like this is your, if you, where is our normal Databricks? Yeah, if you go to this workspace, I go to the compute. Yeah. So while you create a compute here, okay. So this allow us the community edition, the computer development after idle period of 2 hours. Okay. And this is single node cluster has been given to us in this. Okay. There's a single node cluster. Whereas like when you have you wanted to have multiple people can use it, so then the shared one you will create here is. Got the point? But if you use the same thing on Azure Database, then you will get 3 options. One is high concurrency, standard mode, single node, like that. So in normal, just if you log in by using your Azure, normal Databricks, then you'll get these 2 options, shared Databricks and then single node cluster kind of thing. Nikhil, can you share your screen? Like, can you show, this is your, the premium account, right? Can you just show us the premium account?
I can't show any data, but I can show.
Yeah, that's all. Yeah.
Okay, okay, sorry. So actually I was just saying this is Azure, okay, premium version. It was not
Not into this, yeah.
And here I'm just going through that. So in shared compute, like we can able to share, right? This was we are creating the policy, it can be shareable. And this is for performance. This is for photon. I think I have limited options here.
Mhm.
We'll go to already created cluster. So policy, they have created multi-node, okay, and they have created shared cluster, means it can be shared by multiple users. And here is a single user option, or like whatever you're saying that options got changed, I'm not sure. But like cluster modes are not available. Where photon is there, spot instance is there. I don't want to change anything. So. Auto scaling, terminate, driver type, worker type, everything is there, but that like cluster mode is not there. This is Azure.
This is Azure Databricks?
Yeah, Azure Databricks.
Not sure why you're not getting this. When you go into the Azure Databricks and then when you are creating this compute, there you will get an option of choosing. Do you have an IAM access?
Sorry?
You are a IAM access. You having an IAM access?
No. I don't have
That's
IAM.
why. That's why you don't able to see that. So when someone who is creating for you, right? So they can actually create this thing.
Okay, but okay.
Oh, that's what I'm able to understand. So because they choose what kind of mode of deployment you wanted to take it use for this. Okay, let's not confuse ourselves. We will discuss that part. Maybe I will log in Azure, even though I'll show you. Let's discuss like how to use this Databricks user interface.
Yes.
Okay, moving further, let me just share my screen. Here is the okay. So this is the user interface of Spark community version. So right. So here you will get these certain options. One is your workspace. Okay, workspace where all the work that you might have created. This is the I think you all are here right now, correct? Yeah. So
Yes.
um, in works, whenever when you wanted to create here, the three things that in Databricks you will get. The one is called when you create a new, three things you can do. Either you can create a notebook, you can create a table, you can create a cluster. Okay, and for this, the very first thing you require, you need to create a cluster. Okay, because it has to run your program with some certain computation power. So for this, if you just go click here and you will create a cluster here, so you can see that you can name your cluster here in Databricks community version. It will allow you to create for 15 GB of memory. You can use free and community edition, and 2 hours this ideal period this cluster will run. Okay, this is the configuration of this Databricks community version, and you can use any one of the Spark like version here. Okay, we have all the versions here available. Okay, you can use any one of the Spark version, and you can Spark config here also. Here it is something you can Spark config environment. You can define like this is the Spark config you have environment variables also. So this is a configuration basically in Spark config to fine tune the Spark job performance. Okay, and this is the instance. So once you create this, let's say I'm creating this, it's going to display here your compute task has to be created. So it is creating the compute Spark cluster for us. Okay, so any worker node when send the program, this has to be created, this has to be done, this has to be submitted the job. Okay, this is the meaning of this is cluster that we are creating. Let it deploy first.
So cluster is nothing but a set of computes.
Huh?
Cluster is nothing but a set of computing power.
Yeah, it is allocating some hardware for us, okay, so that we can run any Spark job.
Dipesh, what we need to add in the Spark section? We need to add?
Nothing. You don't have to do by default. Let it be whatever it is. Just go on instance and just create. I'll show you here. So why Databricks is useful? Like if you remember when I did on Spark, in EC2 when I created it, there I have to mention everything locally, and I need to even if I wanted to check the web UI, I have taken up. But here in this Databricks, I'll show you. Here it's configuring right now. It's not created. You will able to see on this Spark cluster how many different notebooks are running. Correct? How many different notebooks are running? What are the libraries that has been installed? Right now, there is nothing will show. Uh, just a second, let it be. I run this. Yeah, you can see that the Spark cluster has been created. And since the Spark cluster had been created, now you can see that you able to see if there is no notebook right now running, then we are not running any PySpark program on the top of it. There are no as such libraries are there. Even if you want to install a new library here, so from here itself you can type, let's say I wanted to install any new library. I can search here. I can put any file path for library PyP. From PyP we can install, or I can search. Let's say I wanted to install pandas, or let's say call anything other. If the packages are available on that PyP, that will install it for me. Are you getting my point? Hello.
Yeah.
Yes.
Yeah. So from Maven, Cran, Databricks file system, anywhere it is available, it will install in there, right? Then this is the event log. Means event log, what all the time on timestamp, what has happened. So on right now we have created this. It's healthy running, created by Mishra Dipesh something on this particular time. These are the event logs that you will able to see on this cluster. Then you will be able to see here kind of um, driver logs. So right now there is no Spark user interface because we have not run any program. I will show you this. Here it is the drive logs that we have done here. Everything is there. Metric will not show you anything. No apps running right now. And this is a Spark compute UI master. So right now we are not running any DAG or anything. Otherwise, it would show you what are the different stages, any stages is running or not, any how much storage has been taken, and what are the executors, what are the different executors are running here. So it will show you the complete executions, what are the different executors are running what. So it will display every single thing here. So how much memory, which execution task is completed, what are the SQL data frames we have written here, what are the data frames have been submitted, structured streaming if we have done, what is the statistics of JDBC. If you are running any kind of a streaming job, so you would have seen here, right? So this you can even run into a new tab, everything, and here you can display and visualize the stuff. Moving further, there is a metric right now. This metric are not available for community edition. Before it was. So have you heard about Gangila UI? Nikhil,
Yes.
have you used that?
Yeah. That is for cluster utilization, right?
Cluster, yeah. So Gangila UI is kind of a, if I just show you here, it will be look like this. So you will able to see like what is the cluster utilization, how much cluster has been utilized, everything you could have seen this here, like what is the uses of my cluster, everything you could have seen this over there. What is the heap node, like how much the cluster has been utilized. So kind of understanding your hardware. So this will help us to understand your, that's your in your compute task over there.
Basically, cluster utilization, like how we are utilizing the cluster. And Databricks suggests like we should use 80%, more than 80% of cluster utilization should be there. If cluster utilization is 10%, we are paying for all the cluster resources, all the virtual machines or EC2 instances. We are paying means EMR, whatever how it creates the cluster, it depends. And whatever we are using let's say we are using the bigger cluster and we are giving this small workload, small transformations, small job. Then what happens is cluster will be utilized only 5% and remaining thing will be idle. So, but we have to pay for that. So that Ganglia UI is used to see like how we are utilizing the cluster. Either we are utilizing cluster properly. If its cluster utilization is 99 or 95%, it was very good. Like what we pay. And if cluster utilization is very less, then we have to reduce the cluster size.
Yeah, we can say that. So here, this is what the cluster is there. This is how we created the cluster. Now the next is, let's say in Spark, you will get a very good option to access the data. Okay, I will discuss about the Spark Databricks file systems also. But here you can, before you can upload the data using S3 connections, you can create directly, you can create table with UI, user interface, or other data sources. So you can directly read the data from different Snowflake, JDBC, Kafka, Redis, MongoDB. So these are different connectors are also there, right? So this is how you can connect the data stuff from S3, or you can upload the file also. So let's say whenever you are uploading the file, it will get uploaded into Databricks file system target directory. Okay, so I'll show you. Let's say I'm uploading a data, a simple data. So let me just show you. The data, right? We uploaded here. This data has been uploaded. Now there are two things. Either I uploaded the data or I will create table in notebook. So when I create table in notebook, okay, by default it will create the user interface, kind of a user interface where it is running Python PySpark programming for me, and I will able to do kind of a transformation, ETL, whatever I wanted to do. Or I can make some changes using their user interface also. So like I'll show you. First, it has been stored into the file store of table matches.csv. So when I create table with UI, you can see how it will look like. Okay, sorry. So to run this user interface, you need to select a cluster. So we created a cluster here. Then you need to preview a tables. Now wait. Here you can see that the table, the document will be going to be previewed now. Yeah, so the data has been taken up here in the table interface, right? And now you can see all, see by default, this has understood this is a CSV type. This is the delimiter by which it is subtracting. Here you can select the first row is a header. So when I say first row is a header, so it has taken up the first row is a header. Now you can even change the data from here. Let's say you want that this is a string data, and if you want to convert into a timestamp, okay, so you can convert this into a timestamp. You want this to be a, let's say, any kind of data. Let's say matches are here, okay, so it's a string. So DL applied or not. So I can put it. Let's say it's an integer type. Okay, so let's say if I wanted to win by runs, again it is checking this as a string, so I can convert this as a integer, this also as a integer, right? And again, let's say these are all our values, right? Then I wanted to infer schema. What is infer schema? So when we press the entire file into the infer schema, okay, so invalid content column date column over present the table for entry. What? Okay, so infer schema will, create the data into a certain schema, just go through and create a schema of the files that we have. I'll show you something. So, and then this is multi-line, it's showing allow line break inside the cells. So we don't want multi-line even though first row is a header that I have just created it. So once you create the table here, So what the table, create the table. We have created this table. The table has been now configured. Okay, table is now been configured and table is now saved. Right? This is saved now. These all are the values we have. Oh, sorry, it has taken all the string value. I have not made a changes here. So this is the table that we have converted. So it has been now stored into a Databricks file system. Okay, this has been taken up in a Databricks file system. Now, this data now came into this, and this is now here we have data. Now I'll show you something. Let's say I'll just show you here. It's default matches.csv right now, and in workspace, okay, in new, I'm going to create a table. Sorry, I'm going to create a notebook. So this is a notebook, that is also the table. In this notebook, here, this is a notebook. Can you all see that? So here, first of all, this is very similar like the Jupyter notebook that we had. Okay. And you can choose like in what language you wanted to use, either SQL, R, Python. Okay. These all the languages you can actually choose it, right? So whenever you write this kind of a structure, and you want to see what are the different like links we had, what are the different the data tables that we created, what are the different tables we have, so that you can actually define this, and you will be able to create this. So I'll show you up. So let's say I wanted to check what are the different file store tables, what are the different tables are available here. So you can check dbutils. So there are some DB utilities, means in Databricks utilities are there. So functionality in which you can, do understand some basic understanding of Databricks functionality. So with the help of DB utils, you can list some values, you can help, you can do a lot of things about DB utils. I'll discuss. So here my file store / tables. So whatever are available inside table, it will list all the kind of a path. Can you see this? All the either matches we have taken up. This is the path of that table. Yeah. Hello.
So Deepesh, how to configure this? As in the path, like say if we have that file on the local system, how can we use that? I think I missed it maybe.
I uploaded the data in tables, right?
Yeah, can you go back to catalog?
Either you can go by new, you can go into tables, and you can
Okay.
upload a file.
Okay, so here this option was not okay. Got it. Okay, so yeah.
And then one more technique. See, let's say while you are uploading the file, there was more technique. Let's say I'm just uploading another table. Let's say called diabetes. So here is my diabetes data, and when I'm opening it, there is one option when I create table with UI, or directly I can create table in notebook. So can you see that it directly return the file for me, file location, everything. Yeah. Please try this up, guys, all of you. Correct. Then we have our data here. So once you have data here, then if you wanted to convert this data into a SQL table temporary view file, so you can do this. So this is the table that we created, and you can see that this is the SQL command. So you can change anytime you wanted to. So the table, that the data frame that we had now has been converted into a SQL table. Yeah. And if I run this SQL file, this file is here. Now you can run any SQL queries you want. And if you wanted to convert into a Paraquet file, you know Paraquet?
Yeah, DBFS.
Yeah. In a distributed file system, you can convert as a save as a permanent Paraquet table. What do you say? You created a table?
So I said the table creation is done along with data with the file. Yeah.
Table creation along with the
Data. So what are the next steps? Just asking you.
What we need to do further? That's what you're asking.
Yeah.
Oh, okay. I was just waiting, like if everyone is done, then we'll proceed further. Okay, so this is done, right? So this is how we can read the data from, like from our local file system, right? But what if you have a file or data available into S3 data lake, on Amazon? Okay, so right now I'm going to discuss how to mount your, data from S3. Okay, so for S3, what you need to do is the very first thing you're supposed to gonna do that is like you should have kind of first of all you need to make sure that your data, you should upload a data inside your kind of a data S3 in AWS S3. So how are you going to do that? Let me just quickly tell you. So where is our file? So here you can see that we all have created a S3 bucket, right? This is your S3 bucket. So we have created a S3 bucket. Yeah. So in S3 bucket, I have my own S3 bucket here. Oh, that has been deleted yesterday, right? So every day it's getting. So you need to do what? The very first thing you need to do is, you need to make sure that you create a S3 bucket here. So let's say while I'm creating S3 bucket, I will name it. Right. You need to choose bucket. Okay. So once you, sorry, there is no bucket. Everything is got deleted. Once you do that, you know that what you need to do here. Just create a bucket. Yeah. So this is a bucket here. Inside this, upload and file. So we are uploading any file here. Add files. Any just files. Are you following me?
Yeah, we're trying to connect Databricks to S3 resource.
So we uploaded here. You can see this is the file we have. Yeah. Now, once you do this, once you do this, what is the next thing we're going to do? That is, we are supposed to going to make sure that our data, like should, get accessible by Databricks. For that, we need to give a IAM access of your S3. And S3 should have a certain kind of, security and, ARN access on Databricks we will be giving. So for that, we're going to go into, we will be, once we are done here, so we'll go into IAM. In IAM console, I will create a new authentication management policy. Okay, so this authentication management policy, I will make sure that we will have this authentication management policy. So here I will be going to create a new IAM access here, and that I will be using for my, like kind of a, you can see that here are, two group. I create a user here for this. Create user. Well, even we can work with that. I have in morning, I have given this permission, no? S3 permission. Okay, let me create a new one otherwise. Yeah, so bricks data bricks. Yeah. So here we have defined this and we provided this. Now I will be going to custom password I can mention here. So, or even you can put the, this auto available generated password also. So make sure you have your, yeah. So once I'm done with this, then I'm going to do next. And, here I have created this full access. In this full access, I have to give some permission here. I need to attach some existing policies. So here in this attaching, you're following me, right? All of you? So here what you need to do is you can, define this full permission, or you can kind of, once you define the administrator access, you can give administrator access. And even though go next, you can set S3 full access. These two permissions I have given. And next, yeah, if you want to add a tag, you can do that, right? And this we created. So here it's a console AR and everything, access key ID and all. So what you need to do is you need to download this CSV file, because what we want is while we are creating our code on AWS, the password should not be visible. Those stuff should not be visible. Rather, we will be importing as a data frame. And after importing as a data frame, then I will be using it. And then I will be using and taking this as our code. Did you get the point? Hello?
Yes.
So we're going to download this CSV file. That CSV file has been downloaded now. And now what is the next thing we will be doing here is, once you're done with that, then I'll reach out to my Databricks that is here. Okay. I'll go here and I will go into table. Okay. Will be drop the table that I have just downloaded here. Databricks LabCorp credentials. This I will be open. I will going to open it. And I will create table with UI. Sorry. Once I'm done with that, here I will create a new notebook then. So in this workspace, I have already created a file Mountain S3 on Databricks. I'll be going to be here and just a second. So here now if I run this, so the new date, just a second. select the resource. It is asking me to select the resource. So I'm going to attach and run this resource. You can see here the new data that we have created that's called Databricks, this lab corporate database. This is the file that we want to get this, to read by us. We can see this. Yeah. So once you are done with this, okay, so you need to put this in your while you are reading this. So we are reading file type equal to CSV. It's visible to you guys?
Yeah.
Yeah. So file types of CSV and header is true. Like we are making sure that like few things are there. But even before this, there are few libraries we need to have. So for this, I need to. There are few libraries I need to. There add cell above. So few libraries we required before we, because PySpark, I will be discussing on PySpark, just I'm mounting the data as of now. So to run the Spark queries, there is something we need to import is called from PySpark dot SQL dot functions import all functions. So when you put asterisk, it will import all the functions. So these are the Spark functions. So PySpark functions we are importing. Spark functions, right? Also, I'm using URL import URL libraries to import all the URL processing. So when I'm putting any URL, it will able to do the URL processing for me. The URL lib here. So for that, I will be importing URL lib, right? So once you're done with that, once you run this, yeah, you can see that here. Now you need to move on to read the data. So as you can see that I have to read the data. So for this, I have taken file type equal to CSV. First row is header true, delimiter by this. Then I'm reading the format file type option header. First row is header. Option separated by delimiter and the data. This is the data that I need to read. So what is the data? We have pasted the file over there. So this is the table. So this is the table. If you want to see the data frame, this data frame have consisting a string, password, and console sign-in URL. And I'll show you here. If I just show you this data, see, I don't want to show the, kind of what we say, the my password and all. I'm just telling you like how you print a data frame here. So let's say if I have to just show you my data frame. So this is the data frame, username, password, and console signing. Yeah.
Yeah, Fish, one question here. So basically, this is the credentials CSV, right? But how the actual data set is the another one, right? So how?
So right now our data set is into S3. Okay. To access the S3, we should able to manage that S3. We created a IAM role to access the S3 inside Databricks. Okay. So in order to access the database of S3, it will require some credentials. So these credentials required to access that from AWS.
Right.
Yeah. So for that reason, we are writing this. So we had taken this. This is something, this is the username and password are there. Now I will be going to get the AWS access key and secret key from the data frame. I will be going to type into this way. So I will be going to type access key. I will name it key in a AWS keys data frame dot where, and I will define the column. Their username is this. User name equal to the data. Data. Okay. Then we'll select only the access key ID. And will collect the first row. So collect. So I will be discussing you what I'm doing here. So basically, it's in a this one. What we say. This is nothing but it's a data frame. So we are collecting the first element. Okay. So to do that, we are accessing the first element, and zeroth is we are slicing the first element. That's called access ID. Okay. We are accessing the first access ID. So that is access key ID is this. Access key ID. Okay. So now this is our something that we have created, and similarly the same way I will be going to take for secret key. So this is for access key, and similarly, so for this I will be writing it's a secret key AWS key df where username equal to data select secret. Yeah. So what is that? Access key. Yeah. So, and then again, the same thing. Yeah. So this is what I have with me. That is username, access key ID, access secret key, secret access key, secret we have taken up, right? Now moving further, once you are done with that, the secret key, okay. Okay. You need to, there is we need to encode this as well as, okay. So encoding is also required in the secret key. So for that, so we will be that URL that we have, that console sign in. Yeah. So this is to encode that, right? This is to encode that. Okay. Wait. Okay, you need to match this, right? Just a second.
Is my screen visible?
Yeah.
So I did give this path. There is my this thing. So it says credential path not found. So I did try it with
Where you have
this.
invoked the PySpark. Okay.
I'm just doing read CS with you.
There is a certain format. Okay, you are reading using PySpark. Oh, sorry, pandas, right?
The code you shared in the chat.
Can you change it to /dbfs / file stores like that?
Yeah, just do double slash instead of single slash.
Something like this?
Yeah. Can I execute?
Instead of this, you can do what? DBFS, just remove the slash from the DBFS first. Here, this one. And wherever there is a single, can you try the double?
I guess you need to keep the colon as well after DBFS. Maybe you are removed that. Just a second.
Just come out of this. Okay, yeah. I'm getting a new error now.
The R, is it typo?
R, I used it to make it sure that this is a file path.
Yeah.
So this R is used. So the moment I used it and changed it to double slash, it worked. But I think there is some issue with import left for me now again. Some FS spec is missing. Do I need to install this?
You can install and check.
No, not needed. I think, can you try this command? Because everything should be installed. I shared you one command in chat. Can you try that? Like
Okay, 1 second.
/ everywhere.
Okay.
Yeah. So if we're able to import diabetes, then should be able to import this file as well. There is no change in the file, right?
/ everywhere. Tables also. Tables you missed. File store tables.
Okay.
Colon after DBFS. Colon after DBFS.
Sorry, okay.
You remove that starting forward slash before DBFS.
Okay. This one we have to use. I think I'll share you. I'll write one syntax. I remember. File /dbfs / Okay, can you try this syntax? A file, small file, in starting colon. After that, dbfs path in single slash.
Okay. For this part,
Yeah,
is it correct?
Yeah, small f in starting. Okay, file colon dbfs store. Yeah, can you execute? Let's see.
Okay, let me see this itself. I think this was working.
So mm,
Yeah, after this is also.
you're able to create the access key and all.
Sorry.
You're able to you're able to create access key and secret access key.
Yeah, I did upload that credentials.csv to here.
Yeah. So
only thing is now I'm not able to, use the pandas to read the file from the directory.
yeah, so here once the secret key, so I was actually uploading that file, but you need to download this secret access key file. Okay, so here once your access has been created, like I have given this, then you need to create access key here. So
sorry, I didn't get you. I didn't follow through. Can you repeat it?
So let's say you have created your user, right? IAM user.
Yes.
So once you click onto the user, then you need to create here access key.
You mean this?
Actually, the user interface got changed a little bit. So see, once you created your, I'll just quickly tell you from the beginning. See. Let's say I wanted to delete all of them. So here we have a new user we are creating. We are supposed to gonna name it called let's say employee, right? And here can provide this auto generated, let it be. Then attach policies. First is administrator access. And once you define the administrator access and all, then you go to, S3 also access you can give. And next is here. Let me give the S3 access also. Though. Create user. Right?
Do you want to share your screen?
My screen not shared?
No, I'm sharing right now. I don't know. Correct me if I'm wrong. Everybody's on my screen, right? Like the next one.
Yeah, also we are seeing your screen, Deepesh. I think you.
I was able to see the best screen actually.
Yeah, I was also able to, like we got an error basically while creating, right?
Yeah. Can you see my screen now?
Yeah.
Right? Resource in this AWS account, please re-authenticate. What does it mean? Oh. Okay, I did a mistake. I have deleted the main IAM access. I need to check with them. Lavender. Anyways, any one of you can share your screen. I'll create for you. Can you share your screen? Any one of you?
Well, I created it, but I'm not able to upload and read in the Databricks, within Databricks.
You cannot upload anything into the Databricks.
Sorry?
What you're saying, you're not able to upload into anything into
No,
the
no, I was able to upload it into the Databricks, but I'm not able to read it from there, like, from the file store.
While reading, you can use create from notebook, and I think it will generate path there only.
Okay.
Yeah.
Not from that this thing.
No, their path will get created, right? We are getting problem with path. If you create, when you upload, if you like upload through notebook UI, you will get okay. Inside that get the path.
Actually, we need to do different thing here, right? But we don't need to use the credentials file now. Actually, we need to directly create the secret can access on the Amazon console, right? That you need to tell, right? That you were telling, right? And then that we need to use in the Databricks. Hello. Basically, we need to create the secret key and secret access key on the console, right? That we were checking currently.
You need to? Yeah, you need to create secret key and secret access key so that you will be able to access them.
Just now that we were seeing, right, on your PC, on your machine.
Yeah,
right?
yeah, yeah. So once you able to create this, secret key and all, then what the code I was writing directly over there, then we will able to do that. So what the problem was, I was downloading the username password. Rather, I need to download the secret key and secret access key. From there, we will able to access that, and that's how we will able to access the S3 file. What the point?
So in that way, we are mounting this S3
Yeah, just mounting the S3 so that we will able to access the file that is available inside S3.
Shall I share my screen?
Yeah.
So first we need to again create a bucket and etc. Right? Everything.
Yeah, bucket and all need to be there, of course. Without this, how can you create?
Yeah, right.
I have deleted permission has been revoked to me. Need to check with them. You guys can create, have you created, yeah, please share your screen. Just.
I shared my screen. Is my screen visible?
So which one you uploaded the file inside this CSV, S3, right?
In S3 bucket, I have uploaded just now. This is the bucket.
Good enough. Just copy. This is your bucket name, yeah.
Now basically we need to go to
IM,
right?
Yeah. Users. Create user.
This was the main user, maybe it got deleted.
Yeah. So create user. This is the main user. I delete that one only. So I'm not able to. Yeah, just provide user access to AWS Management Console and click that.
Auto-generated password is fine, right?
Yeah, fine. Yeah.
So this user has to be created specifically for that, Deepesh?
What?
For that mounting, this user?
Mounting we are creating. So S3 policy will be adding.
Then attach policies directly, right?
And mention administrator access and S3 policies. First one, so select first one and S3.
Full access.
Yeah. Just create, go below. Next. Yeah. Just, yeah,
Okay.
create. Yeah. Once you're done, then just download this. Just download this file also, because you should have this user console sign in URL and everything. Then you go to, back to the IAM.
Okay. Yeah, here we need to do that step now, right?
Yeah, now here, one where you have two users, click on users. Yeah, just click on this lab corp trainer, just click on that only. Yeah.
Here, right? Create access.
This key, yeah.
Great.
Which one should I? Local
No,
code?
so you are actually linking with third-party services, right? So here, this is for third-party services. The next, yeah, you can tag this if you want to put any tag, or just create access key.
Optional. Okay, this is the one.
Yeah.
This we need to copy, right?
Yeah, just keep it with you, or even you can download, paste this.
Deepesh, what is the difference between this user and access, user credential and access key?
What?
What is the difference between this user credential and the access key?
See, access key is, that this IAM is allowing us that to use this IAM role over there. Okay. The credentials are for IAMs. IAMs having their, like credential, like what are the permissions has been given to this. So.
Okay, from Databricks, do we configure the user credential or the access key?
We will be going to give access key over there.
Okay. Through your access key, it will identify that user. From that user, it will go to the S3. It will access the S3. That's how it works.
When we talk about AWS credential, it's just verifying you, who are you, whether you have a permission to access a resource that you are requesting or not.
Mm-hmm.
Yeah, now here how should we proceed?
So please, the program that I have given you, try to paste all those stuff. First, we'll do accordingly, then we can do by hiding that also. We can do by hiding that also. Just paste that program and put what all the stuff this is asking to us. So no, so this is something, the credential path for your credential access ID and secret access key. Okay. So here, this is the credential one. Are you sure?
No. I need to change that. It's mine.
The one in which you have access ID and credentials, that is, you should.
Yeah. Right. For that, I will have to read the table first, then add the table here, right?
Okay, you all try this. I've given the code as well as I told the steps. Please try this.
Okay.
And
I will have to check on this.
yeah, please, all of you, please check this, all of you, right? You got to know the process, all of you? Hello?
Yes, Deepesh. Yeah. We'll try.
So what we have discussed today, we have discussed about Databricks user interface a bit.